So, last class I have started group capacity in sand and gravel for end bearing as well as friction piles, also group capacity in clay. Group capacity in clay, how to find it out? Assuming as a block failure, find it out the group capacity. Assuming as an individual pile failure, find it out the group capacity. Compare both these two, whichever is smaller value you take as group capacity of pile groups, or particularly group capacity in clay. Now, one example is there. A group of 9 piles, with 3 piles in a row, 3 piles in a row were driven into a soft clay from ground level to a greater depth. The diameter and length of the piles were diameter and length of the piles were 30 centimeter and 10 meter. The unconfined compressive strength of clay is 70 kPa. If piles were placed at 90 centimeter center to center, look at the question. If the piles were placed 90 centimeter center to center, compute the allowable load on pile group for a factor of safety of 2.5. Compute the allowable load on the pile group for a factor of safety of 2.5. This is the question. Group of pile 9 piles with 3 piles in a row. 9 piles, 3 piles in a row. If I draw it, three piles in a row driven into a soft clay from ground level to a greater depth. That means, if this is the group of pile, this is the group of pile, load has been applied, then this pile has been driven in a soft clay, it is a soft clay up to a greater depth. What does it mean? That means these piles are friction piles. Up to a greater depth means the soft clay is there from ground surface to up to a greater depth. That means this pile called or classified as a friction pile, there is no end bearing. The diameter of the pile is given 30 centimeter. This is your 30 centimeter, and embedded length or embedment length is given, this is your 10 centimeter. Unconfined compressive strength of clay is 70 kPa. That means Cu is equal to Qu by 2, 70 by 2 is your 35 kPa. So, center to center distance is given this and this is your 90 centimeter, this is your 90 centimeter. Now, find it out your allowable load, that means you have to find it out ultimate load, then factor of safety is given, from there you can find it out allowable load. So, this is the questions I explained. Let us start with A. First you consider as a block failure, consider as block failure. So, if you consider as a block failure, QG group capacity is equal to CNC AG plus PG L C prime. So, generally NC is equal to 9 for soft clay, C is equal to C bar is equal to 70 by 2, which is equal to 35 kilonewton per meter square. Area of group AG is equal to 2.1 into 2.1. How it is coming 2.1 and 2.1? 90 plus 90, 180. Plus here it is your 30 centimeter, diameter is your 30, 15 plus 15, 30. So, it will be 2.1, that means this is your 2.1 meter and this is your 2.1 meter. So, from there it is coming out to be 4.4 meter square. Perimeter of the pile group is equal to 4 into 2.1, which is equal to 8.4 meter. Perimeter means this 2.1, 2.1, 2.1, 2.1, 4 into 2.1, 8.4 meter. Length is given 10 meter. So, QUG, which is equal to 35 into 9 into 4.4 plus PG is equal to 8.4 into 10 into 35. This comes out to be 4340 kilonewton. Now, QA is equal to allowable load is equal to QUG by your 2.5, factor of safety is given 2.5, which comes out to be 1740 kilonewton. Then second part you consider as an individual pile failure. So, individual pile failure, what is the formula? QU is equal to QF plus QP, which is equal to QC A B, area of B, plus QP is equal to, QP is equal to QC into area of base, because this is a point resistance. QF is equal to alpha C bar AS. So, once alpha is not given, adhesion factor you can consider alpha is equal to 1. So, QU is equal to, or QB, this is your QB is equal to CNC, which is equal to 35 into 9, which is equal to 315 kilonewton per meter square. AB is equal to 0.07 meter square. AS is equal to 3.14 into 0.3 into 10, which is equal to 9.42 meter square. Then QU comes out to be 352 kilonewton. Then U group capacity is equal to how many number of piles? 9. 9 into 352, which is equal to 3168 kilonewton. Now Q allowable is equal to 3168 divided by 2.5, which is equal to 1267 kilonewton. So if you look at the example, I first calculated considering block failure, area of the group, perimeter of the group, length has been calculated, and alpha has been considered as 1, it is not given adhesion factor. Based on that, QUG is equal to 4340 kilonewton. Q allowable is equal to QUG divided by 2.5, which is equal to 1740 kilonewton. Considering individual pile failure, QU is equal to frictional resistance plus point resistance, which is QB into AB plus alpha C bar AS. QB is equal to CNC. This AB is equal to area of base, pi by 4, area of base is your pi by 4 into d square, 0.07 meter square. Surface area pi dl, this is your pi, this is your diameter 0.3, L is equal to 10, 9.42 meter square. QU is equal to 3168 kilonewton. Then Q allowable is coming about to be 1267. If I compare both these two, considering single pile it is 1267, considering block failure it is 1740. Hence, group capacity is the minimum of 1 and 2, minimum of 1 and 2. From there it comes out to be Q allowable is equal to 1267 kilonewton. This is how our group capacity of piles in clay. One example. Now next part is your example I have solved about the group capacity, group of pile, 9 pile group, 9 piles in a group placed in a clay soils, considering a block failure, considering a single pile failure, the capacity whichever is minimum is considered as a group capacity. Next is your settlement of pile groups. Settlement of the pile group. So one is it is due to first one is your elastic settlement of pile group or elastic. Second is your settlement of soil supporting the pile. Elastic because of your pile. Settlement of pile group means first part is settlement of the pile, second part is your settlement because of your soil. Settlement of soil supporting pile. So there are three cases how to find it out settlement of the pile group. Case 1, particularly in clay, case 1, let me put it in that way. These are friction piles. Case 2 will be your end bearing. Case 3 is your combined. Combined means both end bearing as well as friction. Let us start with a friction pile. So, if I consider this is my L, total embedded length is your L. So, this will be your 2/3 L, 2/3 L, and here will be your load intensity, and this will be 2:1 distributions. The total load is assumed for friction piles. Total load is assumed to act at a depth equal to 2/3 the pile length, 2/3 the pile length. Are you getting? For friction pile, suppose this is a pile group, load has been applied, let us say Q. In case of friction pile, to calculate your settlement, what is the assumptions? Total load is assumed to act at a depth equal to 2/3 of the pile length. If this is my length, this is the 2/3 of the pile length, total load has been applied. Then you take it to 2:1 distributions, then find it out what is the settlement at the center, case 1. Now, end bearing pile, in case of end bearing pile, this is Q, end bearing pile. In this end bearing pile, this is the ground surface. Now, what is the assumption in end bearing pile? End bearing pile, generally what happen? If this is my embedded length, the total load is assumed to be act below the embedded length of the pile. Then from there you have to assume as 2:1 distribution, then load intensity will be applied here. How do you know that it is end bearing or friction pile? In friction pile, generally subsoil profile will be homogeneous. In end bearing pile, what will happen? There is a weaker soil, and here there is a strong strata. In case of end bearing, what is the assumptions? The total load is assumed to be to act at a depth equal to length of pile. This is my length of the pile, total load will act at a depth equal to length of the pile. So, this will be 1:2 distributions. Then both end bearing and friction pile, in that case, for combined case, what will happen? Combined case, this is a Q, then what will happen? Combined case, this will be a case of stronger layer, weak soil followed by strong soil layer. So, in this case what will happen? This will become a combined, that means both end bearing as well as friction piles, both end bearing as well as friction piles. So, in this case what will happen? If this is my L1 and this is L2, So, what will happen? In L2, this will be your 2/3 L2. Total load will be acted. Total load will be acted if it is a weak soil followed by strong soil for combined, that means both end bearing and friction pile. In that case, what will happen? L1 part will be neglected. In L2, total load will be assumed at a act at a depth of 2/3 of L2. From there, you have to go by 2:1 distribution and find it out your increase in load at the center. That means then from there you calculate your settlement of the pile groups. There are 3 cases: case 1 friction pile, case 2 end bearing pile, case 3 is your combined pile. Friction piles, total load is assumed to act at a depth equal to 2/3 of your pile length. End bearing pile, total load is assumed to act at a depth equal to length of the pile. Combined pile, total load will be act at a depth of 2/3 of L2, not in L1. Then from there 2:1 distribution you find it out the settlements. So, this is how you are going to calculate your settlement of the pile group, particularly in clay, how to find it out settlement of the pile groups. So, then settlement of pile groups in particularly clay. Now come to sand for cohesionless soils. For cohesionless soil, Meyerhof has given a method. Sg is equal to 9.4 Q root over of Bg I divided by N. N is equal to corrected SPT, that means below tip. Sg is equal to settlement of pile group in mm. Q is equal to load intensity, which is equal to Qg by Ag. Bg is equal to width of the group, I is equal to influence factor, which is equal to 1 minus L by 8 Bg, which is greater than equal to 0.5. L is equal to length of pile. It is based on your SPT. This is based on your SPT, standard penetration test. So, similarly, CPT, cone penetration test, based on cone penetration test, Sg is equal to Q Bg I divided by 2 QC. QC is your average cone penetration resistance within the seat of settlement. So, this is about your cohesionless soil Meyerhof has given based on SPT and based on CPT. Now, clay soil I have explained how to find it out, but the formula is that for clay soil delta S is equal to Cc H by 1 plus E0 log 10 sigma 0 prime plus delta sigma by sigma 0 prime. Consolidation settlement, how you are going to find it out. Then compression index you can find it out, and increase in stress also you can find it out by means of 2:1 method. How you are going to find it out increase in stress? Delta sigma is equal to Qg divided by Qg plus Zi into Lg plus Zi up to that depth. Suppose this is my pile, suppose this is my pile. In this pile, suppose it is a friction pile, I start with 2/3 L. From here if I move like this, then at the center here it will be your, suppose this is Zi, Qg is your, Zi is your distance level from the application of load at the middle of the clay. This is my Zi, load plus Zi, Lg plus Zi, total L by G, it will be Lg plus Zi. So, increase in stress you can find it out. So, this is what how you are going to find it out settlement in pile group. So, I will stop it here. Next class I will solve a problem on settlement of the pile groups, complete one case, how you are going to calculate it, whether it is a friction pile, end bearing pile, or both considering friction and end bearing pile. Thank you.